Now we're going to take a look at evaluating functions, and we're going to look at several types of functions. And this first function is actually a linear function. Hopefully you recognize it as y equals mx plus b. And if we want to evaluate any function, right, here is my function notation. F of x is equal to 3x plus 1. And in this, we're just saying we want to evaluate. We're given an input of -2, and we want to find the value of the output. So everywhere I have an x, I'm going to put in -2. -2 plus 1. 3, this time my input is -1. So everywhere there's an x, I'm going to put in -1. -1 plus 1, and so forth. 3 times 0 plus 1, 3 times 1 plus 1, 3 times 2 plus 1. And this is going to equal, okay, 3 times 2, -6. This is going to equal -5, -2, 1, 4, and 7. And this actually, and here's the graph here, we could actually write this as an input-output table. For instance, when I input -2, I get an output of -5, and we could plot that. That's what this point here. When I input 0, I get an output of 1, input 0, output 1. When I input 2, I output 7. So this point here would be 2, 7. So if I think about it, is there any inputs that I would have to exclude? Well, I've already put in negative numbers, right? -2, -1. I've put in 0, and then I put positive numbers. I could keep putting in really negative numbers, and what would happen? If I keep getting more and more negative numbers, my y values will keep getting negative. Okay, if I keep getting bigger and bigger in my input values, my y values or my output values are going to keep getting bigger. So there's no inputs that need to be excluded. That means that my domain or my inputs can get really small all the way to -infinity and really big. Or, in other words, all real numbers. There's no restrictions. And similarly, if I think about my output values, like I said here, as my x values are getting bigger, they're going toward positive infinity, my y values are going to keep getting bigger toward positive infinity. As my x values get closer and closer to negative infinity, they keep getting smaller, my y values keep getting smaller as well. So my range is -infinity to positive infinity, all real numbers. That's linear. That's always true for linear functions, always. Let's take a look at quadratic function. In other words, another way that we could describe that is the squared function, meaning I have a squared term here. So I've got my function defined here as f of x is equal to 2x squared plus x minus 3. If I want to evaluate that, I have an input. Remember, my input is inside the parentheses. If I input -2 for x, I can evaluate that to find the output. When I input -2, what's my output? Well, I just substitute in -2 everywhere there's an x. In this one, the next one, I'm going to substitute in -1 everywhere there's an x. Now I'm going to substitute in 0 wherever there's an x. And so forth. I can keep doing that. All right. So this is 2 times 1 squared plus 1 minus 3. And then 2 times 2 squared plus 2 minus 3. Okay, and so all I would have to do is to plug that into a calculator. We'll do this in Excel as we progress through the course, but if I take my first, I'm not going to do all of these, but if I take 2 times negative 2 squared minus 2 minus 3, that gives me a positive 3. So when my input is equal to negative 2, my output is equal to positive 3. Let's do 0. When my input is 0, what do I get? I get negative 3. And let's do this last one. When my input is positive 2, all right, positive 2 plus 2, my output is positive 7. And here I have it graphed. If I just take a look right here, when x equals 0, y should equal negative 3, and that's what I have here. When x equals 0, y is negative 3. And I can take these points and graph them. It comes up with the coordinates. Okay, so let's talk about, are there any inputs that I would exclude? Well, I put in negative numbers. I put in 0. I put in positive numbers. I could keep putting in really negative numbers. If I look at my graph, if I keep getting more and more negative inputs, what happens to my outputs? They just keep shooting up to infinity. If my inputs keep getting bigger and bigger toward positive infinity, what's happening to my outputs? They're shooting up to positive infinity. So there's no restrictions on my domain. I can keep putting in really big numbers and really small numbers, and I'm still going to somewhere land on the graph. So my domain is negative infinity to positive infinity. That's all real numbers. And then let's look though at my domain. Well, I can see here at my domain that this lowest point here is at a y value of negative 3. So I do have restrictions on my range, right? My y value can't be less than negative 3, but it can be equal to negative 3. So yeah, I have restrictions. My y value, the smallest y value is negative 3. We always start with the smallest value here. And it can go all the way up to, well, the y values can keep getting bigger and bigger. So that keeps going to infinity. And for quadratic equations, my domain is always all real numbers, and the range depends upon the specific function I'm working with. All right, let's look at the square root function, okay? This radical sign is the square root of negative 3x plus 3. So if I want to evaluate that, it just means everywhere there's an x, I'm going to replace it with the thing in the parentheses. So this is going to equal the square root of negative 3 times negative 2 plus 3. Now I'm going to input negative 1 for x. This is negative 3 times negative 1 plus 3. This I'm going to put in negative 3 times 0 plus 3. Negative 3 times 1 plus 3. Negative 3 times 2 plus 3. Now, if I graph, since I have the graph over here, we can kind of see, right, these keep going. But, so my input values can keep going toward negative infinity, but it doesn't look like I have any values greater than 1. So let's see what happens here. Let's put a couple of these values in. So I'm going to start off with, I'm going to do the square root of negative 3 times negative 2 plus 3. And, whoops, that gives me a value of positive 3. All right, so when I put in x equals negative 2, I get a positive 3. All right, let's see what happens when I put in 0 for x. I get a y value of 1.73 approximately. Okay. Let's see what happens when I put 1 in. When I put 1 in, I get an output of 0. So let's do this one a little bit further. So this is equal to, I'm going to have -3 times 1. This is -3 plus +3 equals square root of 0. The square root of 0 equals 0. So in fact, I can have a 0 under the radical sign. Okay, so that's equal to 0. Let's try this next one, f of 2. All right, when I put in a 2, and look at what my calculator says. Keep doing that. Undefined. Undefined. Okay, another way to say that is it does not exist. It's undefined. So this is, let's see what happened here. -3 times 2 is -6 plus 3 is equal to square root of -3 does not exist. Why? Because we cannot have a negative number under the radical sign. Okay, so this has to be equal to, greater than or equal to 0. So we cannot have a negative under the radical or under the square root sign. So what I do is I just look what's under the radical here. -3x plus 3 must be greater than, I know it can be equal to 0, right? The square root of 0 is 0. So what I would do is to say -3x plus 3, the thing under the radical has to be greater than or equal to 0. All right? And then I would solve for x, but I can see here that that would be x has to be less than 1, right? It's 1 and then everything less. So I would write that as, and go all the way to -infinity. Oops. Can go from -infinity all the way up to and equal to 1. Right here, okay? And then the range, right? The range has to do with the y values. So my y values are not less than, right? I don't have any negative y values. The y values start at 0. So in fact, this point right here is 1, 0. This is my y value. That's the smallest y value. And then my y values keep getting bigger. So yes, my range would be 0 all the way to infinity. And we'll do more with domain and range as we go forth. Now, the next type of function is what we call a rational function. Rational just means ratio or a fraction. That's all a rational function is a fraction. So anything that has a numerator and a denominator is a rational function. And so we would evaluate this the same way. We would say if my input is 2, everywhere I see an x, I'm going to put a 2. So that's 2 times -2 minus 7 over -2 plus 1. Okay, this would be 2 times -1 minus 7 over -1 plus 1. Okay, this would be 2 times 0 minus 7 over 0 plus 1, and so forth. I'll just fill this last one in. 2 times 2 minus 7 over 2 plus 1. And here it is graphed here, and we can actually see that it looks like we've got this gap here, okay? So if I put this into my calculator, let's do this first one. This is equal to, pull this over. All right. So if I have 2 times -2 minus 7 divided by -2 plus 1, that gives me a positive 11. All right, Let's try f of 0. And no, let's do this next one, f of 1. So now negative 1. So if I put in a negative 1, let's see what happens. Undefined, okay? Let's take a look at that. So this is, if I simplify this, 2 times negative 1 is negative 2 minus 7 over negative 1 plus positive 1, 0. Undefined, or does not exist, because there's 0 in the denominator, okay? That is the only place that this function is undefined. And we can kind of see that here, that at negative 1, I get this gap in my inputs. All right, so when we have an evaluating a rational function, we can't have this denominator equal 0. So the denominator, x plus 1, cannot equal 0. Otherwise, it's going to be undefined. So in this case, x, if we subtract 1 from both sides, x cannot equal negative 1. So we would have to exclude negative 1. So we start off with all real numbers, and we just have to exclude negative 1. Again, we're going to get more into this in later units, so we can go negative infinity all the way up to negative 1. We just have to skip over negative 1, and then we can continue on all the way to positive infinity. Okay? And we can kind of see the same thing on the range or the y values. Here there's a gap, right? And so again, we'll get more into that later. So yes, there are exclusions. Okay. So I have posted a PDF file of our toolkit functions or parent functions, and you should recognize, you'll be expected to recognize and work with all these. I want you to work on these on your own. But basically, if we look at this one, this is the constant function. It just means that no matter what input we put in, we get a constant out. So in this case, we've defined our constant as 2. So no matter what my input is, when I input negative 2, my output is 2. When I input 0, my output is 2. When I input 2, my output is 2. Okay? And so that's those points here, and what that results in is this horizontal line. Okay, another way to say this is y equals 2. So no matter what the x value is, y is always equal to 2. Take another one, the linear function or the identity function. F of x equals x. Another way I could say that is y equals x. So I input x when x equals positive 2. My output, well, x equals y. Okay, so it's just equal to negative 2. And I can graph this here, and that's my linear, or another way to call, another term for it is the identity function. And so you'll go through here, you'll see all these posted, and there's a link that goes through each one of these functions. This will be on the first quiz, and it will be on, most tests will have something about toolkit functions. Okay, that's it.